So in this video I want to talk about integration by parts using a table. And so normally when we think of integration by parts, we think of an inverse product rule, right? So the integral of u dv, before we compute that, we usually break out the u and the dv, right? And then we would take du, differentiate that one, anti-differentiate that, and then we would take the result as uv minus the integral of v du. The problem is that sometimes this integral then also has to be computed, and it can be kind of a hassle to keep doing that. So let me show you an example. And actually in this example I'm just going to go ahead and use this pattern here and see if we can construct a table for our antiderivatives and our derivatives. So suppose I want to take the integral of t squared e to the minus 3t dt. Hope you're going to be able to see that. Maybe I should change my font here just a second. Okay, so that's going to be equal to, now I'm going to take my u to be my t squared and my dv to be e to the minus 3t, and then I'll have a plus sign. So I'm going to be alternating signs just to remind myself about this negative sign. So then I'll have a minus 2t minus 1, I'm anti-differentiating here, and then I'm differentiating here, anti-differentiating here, and then last one, good. And now the pattern that we were using up here looks like u times v, and then we had the bottom had the integral of the v du, and so we'll do the same thing here. We'll have t squared, and then we'll take the product across there and the product across there, and then we'll take the integral of this product. So what is that result going to be? That integral result is going to be minus 1/3 t squared e to the minus 3t. Let's see, we'll have a minus 2t and a 1/9, so that'll be minus 2/9 t e to the minus 3t plus minus 2/27 e to the minus 3t, and then finally we'll have plus the integral, if you want to write it out, of 0 times minus 1/27 e to the minus 3t. But this is just going to be 0 anyway, so we'll just put our plus c. Good, and so that's how you integrate by parts using a table. Good, so let's try another example. How about something like, let's see, let's keep in mind this pattern. How about something like the integral of t sine of 2t? So if I integrate this by parts, I'll have t1, 0 in the middle, plus minus plus. I'll have a sine of 2t, cosine of 2t, sine of 2t. Then I need to take care of these coefficients. So that's going to be a 1/2, and that'll be a positive 1/2, right? This will be a 1/4. Let's see, oops, that's going to be a negative 1/2, sorry, because the derivative of cosine is negative. So, and then here I would need a negative, so that's going to be negative. All right, so then I'm going to have minus 1/2 t cosine of 2t, and then plus 1/4, oops, plus 1/4 sine of 2t plus c. Good, so that's a t there. All right, so now that we have the hang of it, let's try another one. So how about something like the integral of the natural log of x? That's also an integration by parts problem. Let's see, how would that work? I'm going to have the natural log of x. Which column is that going to go in? I believe that needs to go into the middle column because we know how to differentiate that, but we don't know how to anti-differentiate it. In fact, that's what we're asked to do. So I'll go ahead and put a plus, and then natural log of x and a 1. So anti-differentiating this last column, I would have an x. Differentiating this column, I would have 1 over x, and then this would just be a minus. And so in this case, we could go farther, but it wouldn't get us anywhere. So let's go ahead and do this problem. So we have x, natural log of x, minus the integral of 1 dx, which is x. So we have x, natural log of x minus x plus c. Now, just for fun, let's go ahead and anti-differentiate it one more time. What would that be? Anti-derivative of x would be 1/2 x squared, and then the derivative of 1 over x would be minus 1 over x squared, and then we would have a plus there. And you see what's going to happen now? If I were to write this out, let's see what would happen. I'd have x, natural log of x. Oops, it disappeared. And what would we have? We would have minus 1 over x times 1/2 x squared. So that'd be minus 1/2 x. And then we would have plus the integral straight across, oops, that's a minus now, of 1 dx. One-half dx. You see what's going to happen? Okay, yeah, so you see we will end up with the same thing, even if we continue down when we shouldn't. So that's kind of nice. And there's one last problem I wanted to work out. Let's see if I can do it in a couple of minutes. It's this exponential times the sine or cosine. A favorite from Calc 2. E to the minus t, for example, cosine of 2t dt. So in this case, it doesn't really matter which goes into which column. So we'll just go ahead and write them as they are here. Differentiate, anti-differentiate. Notice that I can just write down my sine and cosines here before I figure out the coefficients. And then I'm going to stop here. Let's see, sine to cosine would be 1/2. Cosine to sine will be 1/4 with a negative sign, right? So we get a positive, and then it'll give us our number. Good. And so, what are we going to get now? We're going to have e to the t, 1/2 e to the minus t sine of 2t, and then minus minus plus, minus 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 will give us a plus minus 1/4 e to the minus t cosine of 2t. Okay, but we still have this expression at the bottom, right? So that's going to be a minus 1/4 times the integral of e to the minus t cosine of 2t dt, and now we have the same expression on both sides. Okay, so if you bring this integral over to that side of the equation, what we end up with is, let's see, that's 4/4, so that's 5/4. And so that now is equal to 1/2 e to the minus t sine of 2t. You remember doing these? 1/4 e to the minus t cosine of 2t. And now we would divide both sides by the 4/5, or multiply both sides by 4/5. So if we do that, we get our answer Let's see, this will be 2/5 then? Is that right? And this will be minus 1/5. And R plus C. There you go. That's integration by parts using a table.